Well, good afternoon, good morning, or good evening, depending upon where you are in the world, and welcome to today's DevOps.com webinar. I'm Charlene O'Hanlon, moderator for today's event, and I welcome you. We have a great webinar on tap today, but before we get started, we do have a few housekeeping items we need to go over. First of all, today's event is being recorded, so if you miss any or all of the event, you will have the opportunity to access it later on. Following today's webinar, we will be sending out an email that contains a link to access the webinar on demand. And we are taking questions from the audience. So if at any time during today's presentation you have a question for either of our speakers, please don't wait, don't hesitate. Just use the question and answer tab on your interface and submit your questions. We will try to get to as many as we can near the end of today's webinar. We also have a very interactive chat feature on the interface, so please, we welcome any questions, comments, suggestions you have. You can go ahead and use that chat interface, and we will be sure to chat you back. And finally, at the end of today's webinar, we are doing a drawing for 4 $25 Amazon gift cards. So please stick around. Hopefully you'll be one of our 4 lucky winners. All right, with that, let's kick off today's webinar, which is Migrate and Modernize at Speed with AWS and Moogsoft. Our speakers today are Richard Whitehead, who is the Chief Evangelist at Moogsoft, and Bobby Hallahan, who is a Senior Specialist Solutions Architect at AWS. Gentlemen, thank you so much for joining me today. I really do appreciate it. Richard, I know you are going to be kicking off the conversation, so I'm going to take myself off camera, put myself on mute, and I'll see you at the question and answer session.
Well, thank you very much indeed, Charlene. And yes, I'm going to kick it off today. Welcome, everybody. Hopefully, we're going to share some valuable insights that's going to help you increase your agility while migrating to the cloud. So the agenda, we're just going to recap why the urgency, understand, why this is such an imperative. We're going to have some discussions, and Bobby and I are going to share some insight into the challenges that you're potentially going to face and how they can be addressed, and the resulting benefits. And as we're all deeply engaged with the DevOps community, I'm going to focus on one particular ideal of the 5 ideals, which is focus, flow, and joy. And the ultimate goal, of course, being joy, and how technology can help us get there. So with that, I'm going to hand over to Bobby, and we'll talk a little bit about the urgency.
Yeah, thank you, Richard. So when we think of the urgency of moving or migrating to the cloud, there are a few reasons why we see organizations do this. The first being obviously cost reduction. This is something that if you go back several years, this was one of the main drivers of cloud adoption, being cost reduction. It's cheaper, can be cheaper to run in the cloud. So some of the numbers we'll look at is a 29% reduction in comparable costs, 51% reduction in operational costs, and then with some of our customer case studies, you can see 70% improvement in cost efficiency. We'll go and jump to the next slide here. One of the other reasons we see our customers move to the cloud, or in some cases specifically AWS, is resilience. When we think of running our mission-critical workloads, our business critical workloads, things that can't fail, or things that when they do fail, our organizations start losing money. So if we think of a revenue generating application, I'll use Amazon.com, for example. If Amazon.com goes down, for example, then there's probably a lot of revenue loss associated with that. So by moving to the cloud, and it's specifically looking at the idea of the shared responsibility model, where we're taking care of that underlying infrastructure for you. We've actually found that customers have, in some cases, we'll take a look at these numbers, a 28% quicker mean time to recover, a 48% reduction in severe incidents. And then with one of our customer case studies, they were able to go from an 85% availability rate to 99.99, which is quite impressive. So when we are thinking of why do we see customers moving to AWS and moving to the cloud and migrating to the cloud, we can look at just a couple of those 2 reasons. I think resilience is probably one of the more, at least in my opinion, one of the more important things. Having a application that we know will run at high availability, and then when we do encounter problems, we're able to leverage existing observability tooling and identify those root causes and resolve them quickly. Jump to the next slide. And then, of course, this one is, these last couple are more focused towards our developers, which would be productivity. We can spend less time configuring servers and then more time building cool things. Looking at from a more productive server infrastructure, or having more productive developers, or in some cases, just being able to look. If we take an example of looking at the Washington Post case study, they've moved to 50 plus deployments an hour on their Arc publishing framework. So this really highlights that one, not just the DevOps culture you're adopting, but also a modernization and migration to the cloud. So it comes with real tangible benefits, and the Washington Post is one of the great customer case studies to really exemplify and highlight this. All right. And then lastly, I think this is another point that really points out to and highlights our developers is agility. Not as well as our developers, but then also our business owners as well. So for example, if we look at reduction in time to market, being able to get products out to market to your customers faster, being able to iterate faster on those products. So a 28% increase or 26% increase, that is, in features and bug fixes. So being able to take that minimal viable product, get customer feedback, and iterate it on it quickly to be able to deliver more valuable insights to your customers. And then the last one is shifting some of your spend from just operations to more innovation. And then that's where we find, one, moving to the cloud, and then two, also adopting that DevOps culture is critically important. And this is just a few of the reasons why we found when we think of like the urgency behind this. So with that being said, I'll go ahead and hand it back off to my colleague Richard here, who's going to kind of talk about, while there are a lot of benefits to moving to the cloud, sometimes there can be some challenges as well. Richard, go ahead and take it away.
Yeah, thank you very much, Paul. So yes, all things come with challenges, and the sort of modern infrastructure with all its flexibility and capabilities is no exception to that. So complications, that's probably the first thing we deal with. In some cases, if you're in the process of migrating, for a brief while, hopefully fairly brief, you're going to be managing two environments. So that's by definition more complicated. You're dealing with age in legacy infrastructures, as well as getting your hands around sort of newer infrastructure, and obviously in so many cases newer applications designed to leverage that newer infrastructure. And when you combine complication with high rate of change, which after all is one of the goals and benefits of moving to a modern infrastructure, that presents monitoring and observability challenges. You've got to keep up to date with the changes, and if left just to a human, the result is probably not good. It's probably burnout. You're never going to be able to stay on top of all of the changes and manage the entire infrastructure. So the goal is basically to streamline processes with less resources, and like I say, strive for that ideal of focus and flow. So let's drill down a little bit into some very specific challenges that are created by migration. So I've broken this down into sort of three categories: general challenges that are associated with any form of migration, challenges that are particularly unique to the lift and shift approach. That's where you're taking existing code and existing workloads and moving those to the cloud, and also challenges that occur when you're doing the more direct sort of refactoring approach, where you're completely re-architecting your code for a cloud native solution. So from a general standpoint, one of the things you need to be concerned about is latency. So you're now moving applications or parts of applications that would have been sort of co-located in a physical on-premises data center with little or no latency concerns, and now you're possibly working over the sort of the general internet, and you have to take into consideration the latency. So things that you need in near real time with sort of millisecond latency, you have to specially prepare for that, either through local processing, which we'll cover in a little bit, or other solutions. Aggregation, by definition, the components of your infrastructure are now going to be sort of separated. Maybe it's a blend of infrastructure as a service, software as a service. Another thing to take into account is security. As Bobby sort of alluded to earlier, when you sort of move to an infrastructure as a service solution, there's going to be a shared security model. But also you have to be cognizant of the fact that information is now traversing potentially public communication channels. So as if you were in a completely secure data center, you wouldn't have to worry about that. Now you just have to be aware of, where information is stored in the clear and so forth. And the final point, that's sort of general to these things, is expertise. You're moving to basically different applications, different services, different third parties with the different user experiences, and you just need to build that kind of expertise, and it may not be immediately available. Things that might be relevant to lift and shift specifically is another, what I call proximity. So again, the application that you've been monitoring in your own data center for years is now living somewhere else. So you've got to be aware of potentially the different firewall or protocol challenges that might exist. One very common one that we encounter is people who've instrumented their applications using StatsD. StatsD is a great form of getting time series database, but it's primarily implemented, and historically has been implemented as a UDP protocol, which is not internet friendly. Other considerations would be instrumentation. The application that you've been running as a monolith may no longer have sort of access to native instrumentation, and you'll have to consider perhaps refactoring that or putting a shim on it or something like that. So when you're refactoring and building cloud native applications, there's a different set of challenges. This is generally speaking one of the most successful ways to migrate to the cloud, but you have to be aware of the fact that things are going to be different. It's new code, so chances are the developers are going to be taking advantage of the latest and greatest protocols, and you're going to have to incorporate that and make sure your management infrastructure can accommodate these new protocols. I've got a bullet here that says cardinality. What that means is if you're doing a really good job of building a cloud native application, chances are you're going to be following sort of microservices patterns. You're going to be breaking down your monolith and really taking advantage of the benefits that cloud native infrastructure can provide you. And that means there's more moving parts. So you've got to make sure that you're getting all of that data and handling all of those different things. And again, another sort of side effect of potentially using microservices is we tend to find that cloud native applications, things being monitored are more ephemeral. This is basically because things change a lot, but also because you're taking advantage of the ability to only use the resources that you need. So the elastic compute environment is a good example, spinning up processes and microservices on demand to accommodate load and then turning them back down again. And finally, format. Like I said, application developers are probably going to be leveraging newer monitoring and observability patterns. So you've got to make sure your monitoring infrastructure can handle the different formats of the data. So it's going to present some normalization challenges. So that's touching on some of the challenges. And generally speaking, what we're going to address here is how these challenges are both addressed by the infrastructure as a service, in this case, AWS themselves, and also how you can use third-party technology to address some of these challenges and make it easier to deal with as a human in the fray. So I'm going to hand back to Bobby for the first part of that answer.
Excellent. Thank you, Richard. So when approaching not just cloud migrations, but also just running applications in the cloud, you may hear the term observability or monitoring and observability. And first, what I want to make clear for everybody is what we mean when we say observability and how that differs from historically thinking of just like monitoring or logging. And by observability, what we're really taking is it's not anything super new. So we're like not inventing anything brand new, but what you think of observability is where we take the idea of taking metrics, taking logs, taking traces, and even as well as events, and being able to correlate them together. So let's say, for example, if we take a look at a metric, metrics are great because they give us that time series data points. They're excellent for alarming. We can take a look at, let's say, our P99 latency, for example. And if that breaches a certain threshold, we know something could be wrong. We can alarm on it, and then we can start taking action. However, seeing a P99 latency spiking doesn't necessarily tell us what exactly happened. So in those cases, that's potentially where logs can be helpful. Logs are like those very rich sources of information that can give us, in most cases, probably give us that idea of what the root cause of an error is. And then where traces help us with being able to start correlating information is because specifically in these microservice applications, maybe not as applicable to like more of a monolith infrastructure, but definitely if we are building more cloud native, you're going to be starting to see more distributed components, adopting the principles of loose coupling, and seeing that being able to instrument your application with trace data is allowing you to generate something like a service map where you can see which specific nodes are seeing the most requests, being able to trace a request through your application and seeing where those bottlenecks are, where those errors are. And then by being able to correlate all three of these, and then even starting to take in events, that's where we see the power of observability. So when we say observability, that's what we really mean. Is it's correlating these distinct data types. And of course, there's the argument like, how distinct are these, or are we seeing like a merging of data types? So, for example, you'll start seeing a lot of customers or platforms start emitting metrics in the form of logs, or putting in trace data inside logs. So, in some cases, you'll start seeing where they kind of merge to an extent, or kind of blend in a bit. But I think today it's still pretty easy to argue that these are still distinct data types and data sources. Yeah, so with that being said, we can take a look at what our landscape for observability looks like on AWS. Now, to be clear, this is from AWS supported services. And so if you were to do this on top of AWS, this is what observability would look like. And from this landscape, we'll kind of start at the bottom here, which is e-instrumentation. So this is where we will start looking at specific agents, specific ways to collect those types of telemetry, be it, let's say, if we want to leverage CloudWatch, you'll see the CloudWatch agent being able to collect logs and metrics, or the X-ray agent being able to collect X-ray traces. So if we're instrumenting our application, or even leveraging, let's say, the AWS distro for open telemetry. In other cases, we also have our partners have their own collection agents as well that we can use to collect those logs, metrics, and trace data. Now, if we move kind of one level up the stack here, we'll see where we have the specific, what I'll call data sources, which would be CloudWatch logs. So where do we store our logs in CloudWatch logs? Or where do we store our metrics, be it CloudWatch metrics, or trace data stored in X-ray? From an open source perspective, you can also see this from AWS Managed Elasticsearch, or Managed Prometheus, or storing your trace data in something like Jaeger or Zipkin. Now, once again, I do want to highlight that our partners also can act as a data source, as these repositories of data. And then also, in some cases, they'll also have their own collection mechanisms as well. On top of this, so now let's take a look at we'll move kind of back to the left box here, where we see that mid-tier of different insights we're deriving from these primitive values or source data types. So, for example, look at contributor insights, leverages CloudWatch logs. We'll take a look at synthetic canaries, emit both metrics, logs, and trace data. Or we can even take a look at, let's say, logs insights or contributor insights, or even when we start looking at kind of pushing all this together, and where that correlation happens on the CloudWatch side is with Service Lens. Now, let's say if we have a bias for more of an open source, or maybe we have a very container-heavy workload, you'll see a lot of customers leveraging open source tooling like Grafana or Prometheus. And then this is where you'll see customers potentially adopt something like Amazon Managed Grafana to kind of put that all together. Now, let's kind of talk about where specifically we see like our partners really fill in some gaps here. Specifically, the CloudWatch solution is great if everything's in CloudWatch. So let's say maybe we are working on a project where there is distributed components, and maybe as a team, I can't tell other application teams, maybe there's, for some reason, we can't use a CloudWatch agent, or we're not able to collect logs and put that into CloudWatch. That's where it can get a little difficult to start leveraging and say, let's use everything for CloudWatch, because in some cases it's not realistic. this is one of those places where we see our customers really, or our partners specifically, really help fill those gaps, even in hybrid or multi-cloud environments. Not to say that you can't do it with CloudWatch, but I would say that our partners definitely excel in those capabilities. So yeah, now let's take a look at some of the infrastructure or some of the different types of telemetry we see. So infrastructure, things coming from our operating systems, be it AWS native would be CloudWatch, or leveraging our partners or open source tools. And what I'd like to highlight here is that you can see our partner, the partner column pretty much supports everything. Except AWS vended services. And what I want to make clear here is an AWS vended service, vended metric is a metric that's vended from AWS. So the only way to collect it is from the CloudWatch namespace, for example. Or think of maybe let's think of like a Lambda log, where you set up Lambda logs to CloudWatch log group, and the only way to get that is from CloudWatch logs, or the EC2 namespace, or the ELB namespace, where our customers, and specifically our partners, how they're able to collect that information can be, there's several different ways to do that, be it via a log subscription filter to collect it from CloudWatch logs, leveraging our GetMetric data APIs, or even leveraging our metric streams, for example. Excellent. So with that, I can go ahead and pass it back on to Richard, who's going to kind of talk about a little bit more about how Moogsoft is able to leverage our existing tooling to help enable and empower our developers in terms of observability. Thank you.
Yeah, thanks, Bobby. So yes, so Moogsoft is an APM sort of member, and one of the things that we're trying to provide is a platform that allows you to make the most of all of the instrumentation capabilities that AWS offers, plus, of course, your own sort of custom instrumentation too. But what we're trying to do here is to make it manageable, basically manage the potential chaos. Instrumentation is one of those things where it's sort of be careful what you ask for. If you ask your developers for more instrumentation, they will provide it in bucket loads. So one of the things you've got to be able to do is make sense of the volume of data and basically present it in an actionable format without drowning your operators in just sheer data. So from an architectural standpoint, one of the approaches that we will take is basically pulling data, both sort of event log data, but also time series data in the form of metrics, processing it, using combinations of sort of machine learning and AI techniques. And the goal there is to present it in a human digestible, actionable format that can be used to drive upstream applications such as notification and ticketing. So that's at a very high level. Well, I presented some challenges earlier, and I think it would be remiss of me not to address those challenges in the format that I presented them. So in sort of a direct approach here, we talked about things like localization. That's an ideal of DevOps, right? Localization and simplicity. So one of the approaches that you can use to address latency is sort of metric streams. It's a service that AWS provides. Streaming is always a great way. Anything that can avoid polling is going to help. Where that cannot be addressed, then localized collection, and better still, localized processing. So if you really do need sort of millisecond granularity to understand what's going on, that's a great way to address that with localized processing. You're going to handle the volumes of the data from an aggregation where you're getting all of these different data formats. We're not standardized yet, so there's a lot of proprietary data formats. So consolidation and normalization of the data formats, very, very useful to do that at source. And building intelligence into an application is one way of addressing the expertise gap. If you have a couple of people who really understand the underlying data, it's basically just the form of reducing the whole notion of reducing toil that an SRE would do. That's what you're doing with sort of using AI-based solutions. Is you're essentially embedding the expertise into the application itself. The things that you would do by writing rules or scripting or doing manually now becomes part of the actual application that's monitoring it, and that enables you to do things like correlation. leveraging natural language processing. A good example of that would be, for somebody who's been writing regexes for many, many years. NLP is definitely something that's improved my life. What we can do there is basically take advantage of tags and labeling, something that any reasonable deployment within AWS would have. Make use of their incredible flexible naming and labeling capabilities. But people spell things differently. People use different words. An example that I'll use in a demo in a little bit is a checkout application. So the question is, is checkout capitalized? Is it camel case? Is it two separate words? One of the things that NLP can help you with is understanding that by using STEM words and that technology. That enables you to very quickly create an incredibly powerful and flexible rule that says any word that is similar is good enough. Okay, I'll pause for a second because it looks like my screen is not sharing. So specifically, when you're looking at, say, a lift and shift approach, again, this is where the localization comes in, the edge-based processing. You can co-locate a collector process or an agent alongside the application that you've moved, and that's one way of gathering the data. So that will handle things like the statsd issue of UDP. So UDP basically is only used directly to access the data from the application, and then it's converted to a more web-friendly protocol such as HTTPS to send back to the SaaS application, which in this particular instance would be the Moogsoft application. Also, custom ingestion APIs. If you're doing a lift and shift, it's possible that the application that you're moving is something that cannot be refactored at all. So you're going to have to live with whatever instrumentation methods that they've used. It might be something fairly arcane like syslog or something like that. In that case, you can take advantage of sophisticated APIs that allow you to normalize and process the message on ingestion. So you're not using prescriptive APIs. You can use some legacy customized applications. When you're refactoring, the ability to deal with these new and novel data types, you're looking for an application that has a very powerful normalization capability, but preferably in a no-code format. So the ability to map fields, even if you're dealing with something as fundamentally as simple as a webhook or a REST API, at some point there has to be some kind of data mapping. Fields might be named differently and might need some processing. So the ability to have essentially what we call a workflow engine to process that message and convert the data and extract features and so forth, very powerful indeed. And something else that we've developed that our customers find really useful is the concept of auto classification. Again, that's something that leverages the power of NLP to look at the message content, and from the message content determine the data type that the alert message refers to. So if there are words in there that sound like it might be some kind of network transaction, that can be classified as a network message, and the same with things like storage or compute. So these machine learning techniques really provide a lot of the expertise that would otherwise you would need to hire people for or to train, and all of these things. People are hard to get. They take time to train, and all of these things are going to impact the urgency and agility of your migration. So those are some very specific data points. I alluded to the fact that we have some of this capability in the form of a software as a service product, and that's basically what we're seeing here: the ability to ingest data from multiple sources, time series data, the ability to monitor time series data and use some kind of adaptive thresholding, because again, thresholds are something that require expertise. They're manual, so we offer an engine that will look at data, go through a learning period. It doesn't have to be very long, go through a learning period, understand the normal operating range of a particular metric, and then apply dynamic thresholds based on what's been learned. So again, it just makes life so much easier. It's more adaptive. If something changes, then in a sort of an operation environment, you now have two choices. If you do a code push and a particular metric changes dramatically, let's say memory utilization. Now, there's two possible outcomes here. Either the code change was intentional, and that we were anticipating an increase in memory utilization. You are, after all, at this point, using your resources more efficiently. You can simply choose to ignore that, and the system will adapt and learn the new utilization value over time, and that will become your new norm. Or, of course, you can say, no, that was not anticipated. We certainly didn't intend to use all that memory, and maybe do a rollback. So it gives you choices now. So that's the kind of thing that you're doing with this modern infrastructure and capability. The other thing, of course, is the correlation, the ability to look at the messages that you've aggregated from your various sources, not just across the pillars of observability, but also right across your infrastructure, from the applications to CloudWatch. Take that data, and by using techniques like NLP, identify patterns and identify messages that are somewhat related. NLP works really well with tagging. I can't emphasize that enough. And the goal there basically is to group related events. So rather than dealing with individual alerts and alarms and errors, you can see that they're related. That reduces the volume of data that you're presenting to operators. That reduces pager fatigue and burnout. And it just makes it much easier to zoom in on the issue and identify the underlying event. And obviously the goal here is to automate this as much as possible, so that when these events occur, a ticket is raised, somebody's paged, and that the time from an error occurring to an operator being made aware of it is reduced dramatically. So what does this give you? An obvious benefit, of course, is reduced downtime. That's a key metric by anybody's definition, SRIs in particular. You want to reduce the amount of time that the system is not operating. That basically protects your error budget, gives you more latitude to make changes and do the things that you really want to do, which is push code changes and improvements out. The automation is incredibly important. The ability to do things that would otherwise manual, even if it's just a case of looking at something and trying to make a decision. If that can be automated, then you're reducing toil and spending less time operating and more time innovating. The goal there is to do more with less, free up that time for innovation and increase productivity, and have people spend more time doing the things that they want to do, like improving services and aggressively automating toil out. So one example of why this approach is important is one of our customers who have aggressively moved a lot of their workflows, to AWS, and have seen significant improvements from using sort of the AI and ML-based capabilities. In fact, a 99% reduction in alert volume. Didn't have to hire people, even though they were growing like a weed and adding new capabilities and new customers all the time. That's not something you can address with headcount. And importantly, there was a 66% reduction in customer help desk calls. So customer satisfaction was improved, and the operators' daily lives was made better. And the quote from that, as you can see, is that legacy systems can't do that. You need modern technology to address these issues. Okay, so it's quite a lot of talking for now. So what I'm going to do is very quickly show an example of how this is used in practice. And this is a live demonstration, so hang tight, and hopefully everything will work fine. So, okay, what I'm going to do here is make something happen. So while the screen's a little dull, so we're going to look at something a little bit more interesting. So we can see here, the system has consumed various events from various sources. There's a lot of data coming from different applications. What we're looking at here that's interesting is we're seeing some data coming in from CloudWatch. So there's something going on. So I'm going to go back to my incident view. Okay, and now we can see something's broken. So what's happened is I've caused an error in our checkout service. As you can see, the service label is checkout. That's basically allowing us to group together multiple events. And we can see right now it's impacting, we've clustered together 5 alerts from 5 different nodes. And the common theme here is the checkout service. And as I said, spelling mistakes change, or a different thing like check space out, not a problem. NLP handles that for us. I'm just going to refresh that. Yep. So the incident is continuing to gather in data. So let's zoom in on that and you can see some of the events. You can see we have an incident affecting multiple nodes for the checkout service, and we can actually look at those underlying events. Okay. So now, rather than having potentially in this instance, it's like 13 events or so. So rather than getting 13 notifications, or rather one obscure notification and having to manually correlate these together, we can see that all of these errors are related to the same basic issue in the checkout system. And we can very quickly look and see that the most likely cause is going to be this sort of this crash in a Java application. So very easy to identify what the problem is and jump on it and start resolving the issue. We can see there's some underlying metrics associated with this as well. So we'll just take a quick look. Oh. Move on. I'll take a different view. Okay. So you can see there that there was an example of the dynamic anomaly detection, where we've established a baseline for this particular metric. The shaded area that you see is basically the calculated normal zone. And we can see here that when things started going wrong, we very rapidly exceeded those thresholds and generated some events. And as you can see, as it got worse, the severity of the error increased to accommodate that. So what can happen is we can obviously resolve this issue, or just simply wait for the problem to go away. The system, if it sends sort of happy messages again, clear messages, those messages will be captured and resolved. So that basically touches on a bunch of the points that I mentioned. We've got the various data sources from AWS, including CloudWatch, custom sources from underlying applications, as well as third-party products that are also in the mix that are monitoring various components and sending their own alerts. So with that, I think this seems like a really good opportunity to jump to Q&A. And
excellent. Yeah, so we've gotten some great questions in so far, but there is plenty of time. If you've got a question for either Richard or Bobby, please go ahead and use either the question and answer interface or the chat interface, and we'll be more than happy to move it over for you. The first question here we've gotten in from Hanumantha Rao, who asks, are you planning a Grafana, like Grafana Enterprise Stack, input direct UI wizard integrations as well with MOC?
So the answer is yes. I don't have any specific dates, but yes, absolutely. The ability to provide some dashboard capability, really useful. Our application sits at that really convenient central point between the instrumentation layer and the ticketing layer. So we have the ability to come up with all sorts of useful sort of metrics that can be used to provide transparency to the how operations is doing, and very useful for providing critical data on SLO capabilities and objectives that can be passed up to upper management. So yeah, Grafana is going to do that.
All right, great. Next question is from Paul, who asks, what's the average MTTR time save when troubleshooting an event issue with Moogsoft AI Ops?
Oh gosh, definitely sort of individual results are different. So I don't know what the average is, but some figures that we do see that are very, very consistent is sort of almost immediately, without any real effort, we typically see we see things like the 99% reduction in sort of volumes. That's important. We see typically anywhere between 50 and 75% reduction in ticket creation. The impact on MTTR is different because obviously what we're trying to do here is provide MTTD reduction, which is the time to detect. So that's a critical component of MTTR, but obviously you've got to restore that too. However, we're working with a bunch of partners that provide auto remediation capability, and when you put those two components together, the rapid detection, the automation, and the auto remediation capabilities through sort of northbound webhooks, we're seeing some really, really impressive figures. Basically, customers are reporting that resolutions that typically took hours now take minutes. So, like I said, individual results vary, but that's a reasonable assessment and very consistent.
All right, great. Once again, guys, we have plenty of time for questions. So if you do have one, please go ahead and get it on in. We have a question here from Guillermo. This seems like it might be a little bit more general, and maybe Bobby can jump in on it as well. What is your opinion for the Latin American market regarding AI and machine learning? It's kind of like I said, it's a general question, but interesting one.
Yeah, I guess I can take a shot at it. Unfortunately, I don't have a very prescriptive opinion based on regional geography, or based on different geographic regions for the AI and machine learning market. I'm sorry, that's not the best answer, but well, if there's anything specific that you're looking for, please feel free to post like a follow-up question, or if there's any more details, more than happy to dig in.
Well, he did actually put in chat that Huawei has a tool called i2000 since years ago, able to monitor like this, which could be something, could refer to something, Richard, you were showing on screen. He says, I cannot imagine how this kind of system will be leveraged with AI and machine learning. So I'm not entirely sure where the connection is there, but Guillermo, if you can perhaps elaborate a little bit more in the chat or in the question and answer tab, then we can certainly revisit your question. But while we're waiting, guys, like I said before, lots of time for questions. So go ahead and get one in if you got one. But here's a simpler question for you: is Moogsoft available on the AWS marketplace?
Yes, it is. Absolutely. And I don't know the full details, but I understand there's a promotion going on now. So now will be a great time to go check it out.
Awesome. All right.
And I'm going to have a stab at answering this question based on the questions I've been asked by other people. So, which is, there's two ways of maybe three answers to the question. There's, does the solution have sort of global sort of appeal? The answer is yes, absolutely. The main part of that is basically making sure that the solution is available in various regions. So it is hosted in multiple AWS regions. So that's probably one of the biggest challenges that most businesses have is the location of the data. In terms of the applicability of artificial intelligence, at a very high level, artificial intelligence has basically not been greatly well received in the IT industry. And that's because when the IT solutions and the IT issues and challenges tend not to be big data challenges. There's a lot of data, but it's not a big data issue. You're not trying to identify and sort of human behavioral concepts and things like that. Or so where we found where best success occurs is when you start really tuning the machine learning capabilities to address very specific problems. So what you have is it's not just generic AI, throw a load of data out, see what it comes up with. These are basically machine learning models that have been designed very specifically for IT and infrastructure-based problems and resolutions. And then the third component is language. So I've talked a lot about natural language. So the good news is language works the same. It can be different, but the machines are very good at understanding languages. So particularly when it comes to sort of machine data, so we're talking about logs and structured messages. They tend to follow basically the same format. There are certain regional differences for words like computer or compute and things like that, but that's well within the capabilities of most natural language processing algorithms to handle. So very portable is the short answer.
Excellent. Excellent. All right. We've got a couple more questions. And John asks, what do you guys think about using AI to perform impact analysis and change risk score?
So I don't know if I can answer that question directly. Change is a very important component. I don't know that we're doing anything specifically to look at change management. That's definitely a growing part of the industry, and it's an area that I think Gartner believes is going to be addressed by AI within the next 5 years or so. Do we have anything today that's explicitly focused on change? No. From our standpoint, change is something that it's basically a notification. So that's informational. So if you were to look at a cluster of related events, and one of those events was a change event, I think in the demo I did earlier, there might even have been a message from Jenkins implying that it was code push. That's the kind of value that you get. So it's basically telling you, very rapidly that a change was responsible for an error, but we're not yet applying that modeling to potential changes. That's something that it's going to be involved in, elsewhere. Now, if you are applying this kind of monitoring technology to staging environments, as I think people should be, then you have an opportunity to identify, the issues caused by changes prior to going into production. But that's slightly different to the intent of the question, I think.
Gotcha. All right. All right, great. So here's another question for you. Stefano asks, how robust is your model to new logs? Which AI ML models do you use to deal with logs, such as deep learning, transformers, frequent item set, etc., things like that?
So I don't have those answers off the top of my head. They are very robust. And the intention is obviously to create machine learning models that are adaptive, so that you don't have to make changes or tune every time you change a log. So they're very adaptable. The exact machine learning techniques, I'm not sure, but I would certainly recommend that you head to our research site. So if you go to the Moogsoft website, we have a research site, and you'll definitely find far more detail there.
Excellent. All right, great. So we are about 11 minutes to the top of the hour. So I think we have about 8 more minutes here. So plenty of time for questions. Let's see what we've got here. The next one is another one from John, who asks, in your opinion, what would be the going forward for the ideal AI ops tool? Graph-centric or NLP-centric, or a combination of both?
Oh, I think it's going to be a combination for sure. Both of those techniques have a role to play. Like I said, NLP is absolutely fantastic in an environment where you're dealing with application logs and people are aggressively using tags. But Graph is incredibly useful when you start looking at dependencies and topologies. So both absolutely have a role to play.
Excellent. All right. Great. Next question here. Here's a good one. So we use Jira Service Management for ticketing. Would this solution work with a Jira Service Management?
Yes, absolutely. Works very well. There's a northbound integration. So when incidents are created, depending on the workflow, that they can be used to automatically generate tickets in Jira. So yes, that's a very common integration.
All right, great. All right. I have one more question here. I'll go ahead and ask it, and then I guess we'll kind of keep the question and answer tab open to see if we get any final stragglers in. But let's go ahead and address this last one here. Let's see. Does the solution work with both on-premises and cloud infrastructures?
So yes, there's a combination of ways of getting data into the solution, either via inbound APIs. So if the on-premises application or system has the ability to post HTTPS requests outbound, that's a very easy way to ingest data. In circumstances where that's not possible, either due to the limitations of the application or perhaps even firewalls or so forth, you can download essentially what we call a collector. It's an agent that can be downloaded to pick that data up and aggregate it and ship it. So very useful in hybrid environments.
Okay. All right, great. Well, that is all the questions that we have in right now. I will go ahead and leave the question and answer tab open, see if we get any final ones in. While we are waiting, I do want to remind the audience that today's event has been recorded. So if you missed any or all of the event, or if you just want to watch it again, you will have the opportunity to do so. Following today's webinar, we are going to be sending out an email that contains a link to access the webinar on demand. And the webinar is also going to be living on the DevOps.com website. So you can always go look for it there. Just go to DevOps.com/webinars and look in the on-demand section, and it should be right there waiting for you. Okay, let's see. Oh, looks like we did get one more question came in through the chat. Tan asks, time series databases can be utilized to detect events. How much improvement on machine learning versus typical time series database techniques?
Again, that's a difficult question to quantify at that level. It's really the goal with applying some of the machine learning AI type techniques is to make sense of the data. So I talked in a little bit of detail about some of the adaptive thresholding and the benefits of that. That can limit the number of false positives and also false negatives. So that makes the system more efficient. It reduces the amount of sort of unnecessary work. It also, because it is adaptive, it can reduce maintenance overhead. So there's a sort of an economic and human benefit associated with that. But generally, the ability to sort of identify, what's going on after thresholds have been broken. That's where we're focusing most of our effort. So difficult to quantify that explicitly.
Yeah, I can take another crack at that too. So let's say if we look at like a stat, like taking, let's say, anomaly detection bands, and so we're leveraging an ML model on top of a time series data point or a time series. And then if our time series falls outside of that detection band, and even if we're looking at like an adaptive detection band where it's changing with seasonality, that works very well, but not for everything. So in some cases, let's take a look at an instance status health check. It's either 1 or it's 0. It's where it's alive or it's not alive. In that case, anomaly detection doesn't do us that much good. But now let's take a look at something where something like a static threshold doesn't work very well. So if we take some sort of business metric, maybe like orders per second or checkouts per second, maybe a daytime peak on the East Coast wouldn't necessarily line up with a daytime peak on the West Coast or the Midwest. So having something that would be an error on a certain time series or a certain time of the day would actually be expected behavior. And then like in those cases where we have daily seasonality, or where you don't exactly know what that error would be or what that error rate would be. So maybe let's take P99 latency. What should that be? Is it going to be the same for every single application? As an organization, can I set a defined standard that P99 latency can't be over 2 seconds and that's it forever? That doesn't really work in practice. And I think in those cases, that's where being able to apply anomaly detection bands and leveraging machine learning on top of time series data points is extremely valuable.
Thank you for jogging my memory there, Bobby. So, analogy is a perfect example of a quick fix. We have an online gaming customer, and concurrent user count is a key performance indicator for them. And it has both weekly and daily seasonality. So the idea is that 7 p.m. on a Friday, the CCU count is considerably higher than 7 a.m. on a Monday, and they're interested in seeing potentially if there are any drop-offs outside the norm. So a static threshold completely useless in that environment, but a dynamic one is much more relevant. So thank you for jogging my memory.
Yeah.
All right. All right, well, we are about 4 minutes to the top of the hour. So unfortunately, that is all the time that we have for questions. We did get a couple of comments come in through the chat. So Richard and Bobby, I don't know if you want to check the public chat and see, if there's anything in there that you want to address. But please, guys, I do, feel free to keep throwing those chats in there until we get to the end of the webinar. But while you guys are doing that, I do want to do the drawing for the $425 Amazon gift cards. So without further ado, let's go ahead and do that. Our first winner today is John J. Congratulations, John. Our second winner today is Angela R. Congratulations, Angela. Our third winner today is Jean E. Congratulations, Jean. And our fourth and final winner today is Mallory C. Congratulations, Mallory. We'll be following up with all 4 of you via email to get your Amazon gift card over to you. So please check your inbox. And if you don't see it there, please check your spam folder. All right, guys. What a great presentation. I was very, very interested. I'm a big fan of demos, so I love watching the demos. But I do want to thank both Richard and Bobby for providing such great information. Always good to hear about the technology. Always good to hear about what you guys are doing out there in AWS and Moogsoft land. So thanks again for your time and your expertise. I really do appreciate it. And I also want to thank the audience for joining me today. Such great information and so many great questions and comments that came through. Really do appreciate that as well. But for now, I'm Charlene O'Hanlon, and I am signing off. Have a great day, everybody, and please, whatever you do, stay safe.
Thank you.